Alright, so now what we're going to do is we're going to look at ordering things when there's some identical elements. And by identical elements, we mean some things that are the same. So these things can either be like this question, identical, oh, that's a rubber, identical wine glasses, or they can be in this question here where we got like identical letters. So there's two different scenarios that we can look at, and we're going to explore what both of them look like. So this first question says, 3 identical wine glasses and 5 identical tumblers are arranged in a row across the front of a cupboard. In how many ways can this be done, counting only the patterns? Normally, if they were all different things, we would just call it 8 factorial, because there's 8 different things, 3 glasses and 5 tumblers. If they're identical, we need to count for the fact that those repeating things don't actually make what we're doing unique. So, and that's the idea about counting only the patterns. So because we're looking at only the patterns, we need to consider the fact that each of these wine glasses is the same, and so the pattern for their placement won't be different. It'll be the same pattern. So we do this by dividing by 3 factorial for the 3 wine glasses and 5 factorial for the 5 tumblers, which gives me 56. So you're dividing by the amount of identical elements that you've got for whatever we are looking at, which doesn't really make it too bad. It just changes what we're looking at. Remember, we're looking at the patterns. Because they're the same, the pattern won't change. And then the second question, how does this change if one of the wine glasses becomes clearly chipped, 2 tumblers break, and they are replaced by 2 identical tumblers different from the other 3? There's a lot going on here. So in terms of what we've got, we now have 8 factorial. It's the same thing, we still have 8. We've got 2 factorial times 2 factorial for our 2 new tumblers that we are putting in, times 3 factorial for the other 3 things that are the same. So our wine glasses, we've lost 1 wine glass, so now we've got 2. So that's going to be my first wine glass there. We've got 2 tumblers, the 2 identical tumblers that are coming in to replace. And because we lost 2 from the 5, we have 3 factorial of our remaining tumblers of the ones that we've initially got. And that's going to give me 1,680. In terms of how things are changing, it really works relatively well, and the only thing you've got to remember to do is just make sure you're dividing by whatever repeats. How many letters of the word parallel can be placed in a line with the 3 L's together? So we can solve this parallel, P-A-R-A-L-L-E-L. If we want the 3 L's together, let's think about how many different ways we can place this. So we can put them in the first 3 slots there. So there's 1 place, 2, 3, 4, 5, 6 ways to do it, because they could either go like this, like a giant collection of 3. There's 6 different ways to place them. In terms of the other letters, we don't care about them, times 5 factorial for the remaining letters. Over the bottom, we need to change this. We need to divide it by 2 factorial, because we have 2 A's. Now, the reason we don't times this by 3 factorial is because all the L's are together. We're including them as one thing. So we don't need to divide it by 3 factorial because we need them to be together. We're treating them as one entity. We're treating them as the same thing, which is why you could also group those L's together as one item, look at the other 5 letters individually, and then have that as 6 factorial over 2 factorial, which is the same as 6 times 5 factorial. And we're dividing it by 2 factorial, like I said before, because we've got 2 A's. Those A's are the same. They matter because we care about where they're placed. We care where the A's are placed. The L's must be together, which is why we don't divide it by 3 factorial. And that gives me the answer A. Final last one. In how many ways can the letters of cookbook be arranged in a line? And then what is the probability that the random arrangement has 4 of the O's together? Looking at the total combinations we can have, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 factorial divided by 4 factorial because there's 4 O's times 2 factorial for the 2 K's because they're repeating, which gives me 840. What is the probability that the random arrangement has the 4 O's together? Like we did before, let's include all the 4 O's as one item, as one letter. That leaves us left with the C, a K, a B, and a K. So that's a total of 5 items, so 5 factorial over 2 factorial, because we have 2 K's. We need to account for the fact that there are 2 of those K's there. That gives us 60. Therefore, the probability for O's is going to be 60 over 840, which is 1 over 14. And so there you go. So that's just looking at arranging identical things together in a row or a line.